Hello everyone, this is Debeshbhattacharya on the Civil Engineering Study and Construction channel. Today in this video, we will explore everything you need to know about the reinforcement of a plinth beam of RCC frame structure building. I will discuss the function of the different parts of the reinforcement of this beam, and with this I will also discuss the detailed function of a plinth beam in a RCC frame structure building. So friends, let's start. Friends, first of all you watch the bottom reinforcement of the beams. In every beam there are two longitudinal main bars at bottom passed over the supports. In addition to that, at midspan one extra main bar has been provided. Why it is so? In fact, in general, when a plinth beam is simply supported, then maximum sagging bending moment, that is maximum positive bending moment, occurs at the midspan of the beam. It means the bottom fiber of the beam is subjected to tensile stress, and to cater such tension we provide the main reinforcement at the bottom, quantity of which will depend to the magnitude of the bending moment. Besides this, the maximum hogging bending moment or negative bending moment occurs near the support. In case of a simply supported beam, the top fiber of the beam is subjected to compressive stress. But to resist the compressive stress, concrete alone is sufficient. So there is no need to provide any reinforcement at top of the beam. But we have to provide at least two numbers longitudinal bars at top as a hanger bar of stirrups and construction and stability of the member. As I stated earlier, that hogging bending moment occurs near the supports. Thus, near the supports at that portion at top, tension is occurs. So this cater these tensile stresses, we have to provide extra top bars, longitudinal bars as main bars near all the supports. So you see here, near all the supports, there are one number or two number 16 mm dia extra bars are provided. But friends, for more safety of the structure, top main reinforcement is required in addition to bottom main reinforcement for plinth beams connected to RCC columns. See in this video, at top also, two number 16 mm dia main longitudinal bars have been provided as the main reinforcement. This ensures the beam can handle all possible moments, provide structural stability and resist unexpected forces like seismic or settlement effects. Now why it is so? In the case of an RCC plinth beam in a building, there are generally no upward earth pressure acting directly on the beam unless the soil below the beam is expansive or exerts heaving forces due to specific conditions such as swelling clay or freezing water content in the soil. Typically, the plinth beam is designed to transfer loads from the superstructure to the foundation and is not in direct contact with the soil beneath. Now it is another point, that is development length of longitudinal main bars of the beam. Development length in a beam refers to the required length of reinforcement bar that needs to be embedded in concrete to effectively transfer stresses between the steel and concrete. This is crucial for ensuring the beam's structural integrity and preventing premature failure, especially at connections like beam column junctions. Friends, see in the video that all the top and bottom main reinforcement ends are bent up as L shape. This bent up portion is the development length of the reinforcement. This development length is essential because it ensures that the bond between the steel rebar and the concrete is strong enough to transfer the tensile or compressive forces applied to the beam. Without sufficient development length, the rebar may pull out of the concrete under load, leading to structural failure. The required development length is influenced by several factors, including the diameter of the rebar, the type of the steel that is deformed or plain, the concrete strength and the stress in the steel. Now what will be the extra length of the bar as development length? For accurate calculation of the required development length, this is as per clause number 26.2.1 of Indian Standard Code of Practice 456-2000. Development length is calculated using LD equal to phi into sigma s divided by 4 tau BD, wherein LD equal to required development length of the bar, phi equal to diameter of the reinforcement bar, sigma s equal to stress in a bar at the point considered at the time of load design, and tau BD equal to designed bond stress. Now going to another reinforcement component of this RCC beam. This is vertical stirrups. In RCC beams, stirrups, which is also called shear reinforcement, are critical for resisting shear forces and holding the longitudinal bars in place and provide additional strength to the beam. You are watching here that all the beams have been provided 8 mm dia 2-legged stirrups. Shear forces are resisted by vertical stirrups as shear reinforcement to prevent diagonal tension cracks. It is provided throughout the span to resist shear forces and hold the top and bottom longitudinal bars in position. Closer spacing of stirrups are required near support due to higher shear forces, and wider spacing at midspan as shear force decreases towards the beam center. For very high shear force, inclined stirrups or bent up bars may also be provided. The specification, spacing and design of stirrups are stated in Indian Standard Code of Practice 456-2000 in clause number 26.5.1.6 and 26.5.1.7 and in table number 5. Stirrup has several functions in this beam. I am stating the functions one by one. Number 1, it resists diagonal shear and torsion. Stirrups resist shear force and prevent diagonal cracks caused by these forces. They are particularly critical in areas near the support of a beam where shear stress is maximum. Number 2, holding main reinforcement in place, stirrups ensure that the main longitudinal reinforcement bars remain in their correct positions during construction and concrete pouring, maintaining the beam's structural integrity. Number 3, stirrups improve the ductility of the beam and ensure that the concrete in the core remains confined, which enhances the beam's capacity to absorb energy and deform without failure. Number 4, stirrups help in controlling crack propagation under loads, improving the overall durability and lifespan of the structure. The anchorage and hooks of the stirrups are also very vital matter for the stability of the structure. For this, we may consult Indian Standard Code of Practice 456-2000 and SP 16. As per IS 2502-1963 clause number 5.1.1, the 135 hook in stirrups is mandatory. The 135-degree bend followed by a 10D extension ensures that the stirrup does not slip or pull out under shear or torsion stress. This anchorage grips the concrete much more effectively than a 90-degree bend. Friends, see in this video that all the hooks of the stirrups are bent up at 135 degree and those are extended up to 10D. Friends, this reinforcement is the backbone of a RCC structure. The correct size, spacing and placement of reinforcement bars as per IS codes ensures strength, safety and durability of a structure. All the reinforcement should be according to Indian Standard Code of Practice 1786-2008, grade of which may be FE 415, FE 500, FE 500D, FE 500 or FE 600, etc. Friends, these were all about the function of the reinforcement. Now I am stating in short the function of a plinth beam. Number 1, plinth beam transfers the loads of walls and structure above it to the foundation. Number 2, It prevents settlement cracks by distributing loads uniformly. Number 3. During earthquake, it acts as a barrier to resist lateral forces. Number 4. It aligns the foundation and provides a uniform platform for wall construction. Number 5. This acts as a horizontal tie to hold the footings and foundations together, improving the building's resistance to seismic forces and structural stability. Number 6. It keeps walls intact against lateral soil pressure as barrier against soil pressure or other ground movements. Number 7 and last, it helps to prevent moisture from seeping into the walls by raising the structure above ground level. Friends, these were all about the construction of a plinth beam perfectly. So friends, if you feel the video is useful to you, please don't forget to hit the subscribe button and press the bell icon all to get the all updates of this channel. Thank you for watching this video. Meet you again. Thanks.